Hello, hello, hello. Hello, everybody. It has been a long old time. I think I haven't streamed for like a month, and well, it was like way more than a month. Been busy with the Skunkworks setting competition and stuff. Been having fun with that. But yeah, when I get back into a bit more puzzling, I've got quite a long list. I'll have to see how we get through. But we're always happy to take other requests as well. Hey, Geo. But yeah. So I mean, I've written that I'm Sudoku, but starting off with a puzzle that's a bit, well, it's close enough to Sudoku, but it's a bit of a funky one, really. So, puzzle by Nurator. You're 0 to 9 across all the rows, and can't repeat, but digits can repeat in columns, and they sum to what they do in cages, and they can't repeat in cages as well. So that's useful. There's a non-consecutive rule, and each region has a defined and assigned suit. So clubs, spades, hearts, diamonds, etc. And then you've got to find sets of 5 orthogonal cells, which then make up each of the individual hands in poker. So it's a bit of a fun one. And the assign each cell to one of the 8 unique poker hands. So there's 8 times 4, which is 40, because we're 10 by 4, aren't we? 8 times 5. So that all works. And yeah, and the last rules is like, if you got a full house, that doesn't count as trips. So I took a very brief look at this when it first came out, but then didn't get anywhere. Hey, yeah, blackjack. We're playing poker rather than blackjack tonight, I'm afraid. And yeah, and as I say, didn't particularly get anywhere. So I'm hoping that might be able to see what's happening at some point with people. I mean, you got the pressure of people watching, but at least you got people to help as well. Evens out, doesn't it? Oh, sorry, I think my mic's peaking a bit. Turn that down a bit. That might be a bit better. Oh, nice. I've been watching far too much Brad Owen at the moment on YouTube. I don't know if you know him, Blackjack, with his poker vlogs. Right, so I've started. And yeah, and regions are the same. So like these 3 digits are those 3 digits as well, aren't they? So because you're gonna have to find some hands that are hard to place, like quads are gonna have to be somewhere around this sort of region, aren't they? And they're gonna have to take something from every row and column. Every row. And then but and your royal flush and your just standard flush, they're not really going to be problematic. You can just hide those away wherever they want, most likely. And the full house could just sit over here, couldn't it? As well. I think it had to have more things around it. Let's keep thinking about the 4 of a kind, the quads, which What cells is that gonna have to? I was about to play 7s and 9s here, but they could sit there. Is there any other? Tell I do irregular, not that much. And I can't actually use column stuff, can I? It is only horizontal, where there's any digits that can't repeat. Anyone seeing it? I should have had more of a look at this before I started the stream so I could make sure I knew what was going on. Yeah, no. So it's the quads. I suppose it's always going to take. So it's always going to take everything like that, but it could easily just do. I mean, it would have to look something like this. Ah, yeah. No, here's a thought actually. Because you can do wherever it sits. Say it did sit something like this. That has to be divisible by 5, doesn't it? So that might be tricky. 6, 12, 13. So being able to, because you're sort of cutting the puzzle in half, aren't you? So you'd need to make sure that you've left things that are divisible by 5 on this side. So how's that working? And oh wait, no. Do you have to take? Have I gone mad? Can you just do that? No, that doesn't work, does it? Because you do have to take the top cell, because these can't repeat along here for quads. Yeah. I think that was what I didn't realize when I was looking at this puzzle before. So in the end, if you did something like that, because it feels like I should just be able to write this. That's sort of the furthest left that you can close stuff off, isn't it? And then you'd have a set of 5 here, a set of 5 here. So you have to shift everything sort of 3 cells over. But the furthest over to this side you can go is that, in order to still be picking up this cell, this region. And is that then 1, 2, 3, 4, 5? That is then maximized. So yeah. So I think that does have to be your quads there, because it's the furthest right you can go with it, because you have to be hitting this region, and it's the furthest left you can go, because everything you're left over with just 15 sort of thing on this hand side. So I think that makes sense. I'm gonna have it as my first region, but yeah, no, I will close it off like that. And then these, wait, which cells? Yeah, these 4 cells will have to be the same, won't they? And they're part of the same group, for example. So they're all from 0, 1, 2, 3, 4, 5. And those 4 are the same, but we don't know which is which particularly. Nice. That is more of a start than what I had before. Are you going to have some sort of flush in here? You got 3 things that are all contained in the same suit. I'm going to get rid of this because it's making it hard to see the regions. You could still fit a flush down here, couldn't you? Quite likely, I think. So perhaps the better question is, does something like a full house now become tricky? Because if the full house was situated over here, it would have to go in all three of these regions, so it would have to look like that, I think. Yeah, that's true, isn't it? And at that point, it could be... Ah. Yeah. Yeah, because both of them are going to have to take three regions, aren't they? And I suppose you could have trips there and then a full house here. If those three are the same and those three are the same and those two are the same. Is it? Yeah. It's close though, isn't it? And of course, once you get down to 2-pair and that sort of thing, then it's very easy. You just need to hop over a single border, don't you? I mean, at this point... Oh, no, hang on. I was saying about how... Yeah, no, this sort of setup definitely wouldn't work because you're struggling to place all your flushes, because this can only take one, and then that would only be able to take a second one. So I think because... Yeah. So this has got to take... Oh, this can take at most one of the three of a kind and a full house on this side, because you can't get between the two regions on the other side, sort of thing. And if this is so you definitely have at least one hand on that sort of jumps into this. So what I'm trying the long-winded thing of what I'm trying to say is that definitely can't be a flush along here. If that was a flush, then you don't have space for one of three of a kind and a full house. So, and the other thing is, as soon as you take out cells that can you build something that leaves enough cells on this side for all the flushes? Like those, that could be your trips or a full house, or and then you could have something like that, just as an example. Yeah, that's a good point with so this one would need a flush for sure. Hey, a bookworm. Let's keep moving. Yeah, so so this definitely has a flush in it, which has to take at least those two cells, because otherwise you'd be doing something like this. zeros are low, so royal flush is 5 through 9. Just wondering if that was any reason here. I don't know why I've got 5s in there, by the way. did we have the exact same thought? Oh, also that. Yes. Yeah. I think that was a misclick. I think I just put in 4s rather than 5s. But yeah, that's interesting. That you know, because it's taking all the regions, isn't it? And isn't 4 used in every region as well? Because the straight flush can't be another royal flush, so the straight flush is always going to take a 4, because it could be 0 through 4, or it would be 4 through 8 sort of thing. So these I don't think can be 4s either. And in fact, that implies that because you've got these 3 cells that are all the same. Let me just circle them or something. Oh, that just looks rubbish. I'll just remember that they're all the same. Then that means that your straight flush has to start with at least a 1. So it only actually has a few possibilities, like it's going to come from one of these, and all of those have both a 4 and a 5. Hey, a startup. Oh, we can't quite do the same yellow colouring. Not that the yellows really does anything in this region, because they could sort of hide around here. Yeah, I think it's that last line. The each hand counts as its highest rating. So if it was 2 from 5 through 9, then it would sort of be going against the rule of you can have only one of each kind. Yeah. If this could probably hide the royal flush. I was just thinking about, because this sort of setup seemed the only way to get hang on a mo. If if either of the trips or the full house were on this side, it has to look like that. That's the only way that works. And then how are you building this region and leaving space for a flush in this space? Because this would sort of have to leave 5 cells, and then that just breaks. So this blue region can't come up, and can't therefore be a triple type region. You can't fit any triple type regions on this hand side. So we do need to find them both over here. And that implies that you're going to take 1 cell from here and 1 cell from here. So that's certainly yellow. And that's got to be yellow. And you can't reach from there to there, can you? Because I was wondering about if that could be your flush up here, and then if these come down, but all of these have got to be part of either the three of a kind or a full house. So you can't take both of those because that's not going to reach. So this does come down and joins down to here, and it can't sort of go around anything. And because this, whatever the other one down here is, let's make it blue again, has to reach up there, then that is the only way they work. Of salmon. I was very confused who Damon was. Yeah, so it's just segmenting the different hands. Sorry, the rules, I don't know if they're particularly readable at all. with how it is. So blue has to take all of that, and I was just worried about if blue could do something like this, but of course that cuts off there. So blue does come down like this, and here is orange. And these two cells are the same, and might and definitely repeat down here. Oh, this has to be trips, doesn't it? Because you've got three in one suit, and this has to be your full house, which is made up of these two types of digits. And no, so the 7-9, because that's got to repeat both here and here. So the 7-9 goes there and there, and then you've got another 7-9 plus a 0, 2, 3, 4 here. Nice. So this isn't your royal because it's losing 7 to 9, and this also isn't your royal because this is losing 7 to 9. So the royal flush is in region 1. And can this be a straight flush? No, it can't because of the 5. If that was 0, 1, 4, or then you'd have 2s and 3s, and it would be broken, or 0, 2, 3, and would have 1s. So this is a straight flush, so it has to be 7 and 9 like that, and comes from these sort of digits. So now that's a 9. Something like this, I think. And 9s now, because 9s don't repeat in rows, do they? So 9s go somewhere here. And of course, we've got to build this hand into this region without messing up this flush, don't we? So this isn't allowed to be the same color as blue because we've checked that already. Let's make that another green. And that certainly is also part of green, because green is the one that comes into here that isn't the flush and isn't connected to blue either. And green can't come down to here, can it? No, and it can't come to that cell either. So blues sit down here, and they're presumably... Oh, they've got to be a straight, haven't they? Yes. Because we don't have one pair, do we? So this is a straight. Doesn't have a 9 in it. Oh, and of course this cell comes from 0, 2, 3, 4. So the 5s would have to go somewhere down here. Hmm. So what have we used? Sorry. Oh, I can't cross this off easily. This is our quads. This is a full house. This is a straight flush. This is a flush, and that's trips. Then you've got your royal flush somewhere here. You've got a straight here. So this has to be 2 pair. So these 2 digits are going to be the ones that repeat in here. And they certainly can't contain an 8 at that point, because the 8 is part of the royal flush. Need to remember that they're all the same as well. So, yeah. So, these all being the same. No. Well, I suppose this can't have a 0 in it, can it? Because it would see these 2 digits in their regions. So this guy, which is a straight, can't have 0, 1, 2, or 0, 1, or 2. Oh no, it can. It could easily have 1, 2, or 3. It comes from those sort of digits, I suppose. I was thinking it had to be bigger than all of the options here, but as long as it's bigger than 1, then that's okay. I was about to get confused why I thought that these couldn't repeat. A, they're in a cage which can't repeat, and B, they add up to an odd number. Oh, our trips should be interesting, shouldn't they? Hang on, can the 8 can hide over here, which I hadn't noticed. Yeah, I thought for some reason that was a triple there. But that can have a 3 and that can be an 8. Should put 8s down here, sort of thing. Because this digit repeats, so it can't be a 0. 1, 2, 3. Well, 1, 2, 3, 8. And that goes somewhere down here with 2 other random digits. Certainly is, isn't it? Can't be 5s. Surely can that be green? Yeah, you could probably snake around like this, couldn't you? Need a 7, but that should be fine to get. This cell, where does it go along here? It's got to go up here. So, and that's not going to be contained within the royal flush. So that's got to be a part of the green one. So if this wasn't green, then green couldn't reach back up. So that cell's green at least. Probably not a very useful deduction. And this cell repeats somewhere down there. Maybe I am going to have to mark some stuff that repeats. So I know they're all the same. I know that these two are the same and also comes somewhere down there. I just realised that our straight flush didn't need a 5 when I was first looking at it, but sort of well beyond that point if that did make a difference, unfortunately. So these are all the same, those two are the same. And whatever these two cells are, which I can colour, oops. Let's make them blue circle and orange circle. Because they're different to green circle and red circle being in this region. They've got to repeat somewhere over here. And orange circle goes somewhere up there as well. What am I not seeing? And this cell has to go somewhere there. But that could easily be on the straight. So an orange repeating here. Oh, and red's somewhere up there. So that could be red if it really wanted to. And then blue and orange just hide wherever they want. Well, once we're at this point, it would be far more straightforward. Red circles down here. This. Oh, hang on. Green, blue and orange. Don't blue and orange have to? Maybe weighs both cells of the 11 cage. I think so. Because they could just be a 5-6 part of the straight. Standard flush, standard. Oh, and zeros. Green would do that, I suppose, wouldn't it? If that was blue. I can't immediately see anything wrong with that. I was just thinking. Wait, why? Oh yeah, because zero can't repeat there. Blue and orange and pink. One of these three is zero. If orange is zero, it goes there. But that should be fine. Ooh, I don't think this can be zero. Oh, yeah, no, it can. Because my question was, where's zero in this region? And if it's there, it's there. Otherwise, it's got to be part of green. As I said, it can't be part of the blue straight. 98765 is what makes up this. 388. I suppose the straight down here, if it has any digits from 5, 6, 7, and 8, they've got to be at the bottom there. But then that should be absolutely fine. That doesn't really matter, surely. These, oh no, these two can be 8s. I was worried about this region, but that's part of that region. Huh. Maybe they have to be 8s. If they're a 1, then that's 0, 2, 3. That's all 0, 2, 3. Orange would go there and there. And then orange is up here. This cell I'm claiming has to be our other colour. Even though it's not very useful, it's certainly not connecting to green. It's not connecting to blue. Here, I say. Double cats. Realised he moved again. No, because I think fortunately startup because of the 5 cage, that's making that immediately not a. Oh god, hang on a mo. No, what on earth am I saying? Because that could be like that. So I have missed an option. Uh-oh. That's bad. I've butchered this solve, I'm afraid. I'll just duplicate it so that I can always get back to where I was. Because at this point, this could actually still be a straight, which I had not realised at all. Because I was thinking I'm getting confused because it's not 9 cell regions. Oh dear lord. Yeah, this can happily if those are 9s. Second time lucky, right? If these were 7s, then you're definitely not, because one of these has to be a straight. They're definitely not being a straight, so it has to be this way round at least. And blue still isn't allowed to come up here, so these two are a new region that comes out in some way. And green isn't reaching any of those, so that's all true still. And because this isn't 2 pair, this has to be a 2 pair and has to therefore take, as that cell repeats up here, it has to take that cell. So more or less where we were. Oh, 1, 2, 3, 4, 9. And that's still, because these two are the same, that still can't have a naught in it. Definitely has a 5. Yeah, this has definitely got this. This has definitely got the royal flush. That's still true. So, I mean, before I got rid of everything we did, maybe I should have just looked more carefully. If this is a straight flush, sorry, then it would have to be 4 through 8. 4, 5, 6, 7, 8. That would be a pair of 1s. Is that a problem at all? I don't think so. Unfortunately. So it's very much back to the drawing board. That cell can't be green because it can't reach there. So if it's 3 or 4, it does have to be part of this. And it can't actually be 3 because then you can't reach. So that's not a 3. How much that does. So it's either. Oh, this maybe is more interesting. It's either 4, 7, and therefore you have 5s and 6s there, or it's big and therefore part of the royal flush. I mean, these cells are sort of restricted because if this was the straight, those would have to be a pair of ones. But if this is the straight, this comes from 0, 1. It doesn't come from 0, 1, 2, 3, or 8. So at least that's still true as well. But even if that is a 4, you can still have an 8 here. Just wondering about getting rid of 8s because this is the same as that, and that repeats down here as well. Hmm. 1, 2, 3, 4, 5, 6, 7, and 8. I just can't see anything wrong with that. If these are 3s, then our straight has to be 4 through 8. But that's probably fine. 3, 0, 2. It's 1 and 8 on the outside. Oh, it would put. So if those are 3s, these are 1s. Oh no! Here's something really interesting. Where do these cells go along here? Oh no, they go there. Oh, sorry. Yeah. Don't know what I was thinking. Could that be a 6, 7, 8 triple, or do you have to have some of 6, 7, 8 there? That can probably be a 1, 1 through 5. Whole bunch of noughts. Surely it can't be our 2 pair. Because now we know. I suppose these go in here, so they do still come from something small. Because these two have to repeat in here. Ah. Oh, this might genuinely be it. So these 3 cells. These 2 repeat in here. Then you've got somewhere a royal flush. Then you've got that cell, which is actually the same as this cell. So in this region, you have a royal flush, plus you have these 3 cells. And then my question is, what does that mean about the cell that's left over for our straight? Yeah, that pretty much sums up my feeling at the most up. So you've got these 3 circled cells. You've got the royal flush, and you've got 1 cell for the straight. So, and I know the cell for the straight can't be a 0. If the cell for a straight was a 1, that's just fine, isn't it? Oh, and you've also got the other cell that makes up this. I knew I was miscounting one. There's another cell that is our leftover guy from our 2 pair. I'm gonna ping Nurator and see if he wants to give us a hand. Hopefully at least got the hands. hands in the right place. We'll have to see. I mean, where else can you do anything? If that's 4, that's 7. You get 5s and 6s there. And then there's the question about 1s and things like that. And blue goes somewhere down here. But blue's still allowed to be part of our straight. Yeah, the lack of difference in the columns is really throwing me. And this cell goes somewhere up here. Nurator's busy at the moment, unfortunately. Right, I'm gonna leave this puzzle for now, and then come back to it when hopefully things they might get a hint or go see it. What is the value of 4 of the kind? Is something that Nurator's just asked. At the so apparently the 5 cage is interesting. Have I got? If these were 3s, 3s but 0 and 2, right? Threes, 0 and 2 would mean that 1s and 2s put 1s along here, but then these that could be 1s as part of the trips. Or if these are noughts, surely doesn't mean much. 1s, not 4s. 1s, not 4s at least mean that this is a straight. Does this? No, this doesn't have to be a straight given what the rest of it is. Like I've noticed that 5s and 6s are in here. Ah, hang on a minute. If this is a, I'll follow on this last thought, and then I'll have to move on. If this is a straight, it's 8 through 4, and therefore that's 0, 2, 3 with 1s. So you've got 8, 6, and 5 there. So that one of these would have to be 4s, repeating there. And therefore, if this had a 4, which it does have to have, it would be down there, but I think that's fine. 4s and 5s. Because I was worried if you'd end up with 2 straight flushes. But yeah. Right. I'll leave this for now. Let's move on to another puzzle and then see if like the solving brain gets back in gear at all. Right. Puzzle by Chad next. Let's have a look of what that looks like. So, quite a minimalistically clued grid. Clues outside the grid are X sandwich clues, where the first 1 or 2 digits seen from that clue, read in reading order, give the sum of the digits between the 1 and the 9 are sandwich clues, where the first 1 or 2 digits seen by that clue. Am I interpreting the rules right? That I'm trying to work out what the 1 and the 2 mean in this instance. Because it's just... Yeah, sorry, I was just having a look on the LMD page. So anything with a 2 is a 2-digit number between the 1 and the 2. And anything with a 1 is just a 1-digit number. So... what's the biggest sandwich you can be? You can be 35, can't you? So all the things starting with a 2 are going to start with a 1. Start with a 3 even, sorry. Start with at most a 3. So you get 1, 2, 3s. And if they were a 3, like especially this one, oh, they are read in reading order, sorry. Top to bottom or left to right. So that's 1, 2, 3, or that's 1, 2, 3. Yes. Oh, so you get 1, 2, 3 triple. Nice. And so certainly one of them and these two are the same. Yeah, that's some more 1, 2, 3s. So if this was a 3, oh, you could be 3, 2. No, I think you can with something like that. That should sum to 32. If my maths is right. No, that's only 30. What am I on about? Oh no. Where the hell's that rule gone? I completely forgot about the non-consecutive. Let's go back. Let's go back to this. How did I forget about the non-consecutive stuff? Oh, that was a bit silly, wasn't it? So, hang on, let's undo this. Oops. Let's undo this. Let's go back to this quickly. So if this is a 3, then that's a 0 too. Oh, sorry. That is exactly what I am, to be fair. So these have to be noughts, and this has to be a 2-3 pair. That should make things a bit easier. Oh dear lord. Whoops. 1, 4, 2, 3 there. This Can this have a 1? Yeah, it can, because blue circle that repeats down there can happily sit over here. None of these are consecutive, which is interesting. This could still be the pretty much. Yeah, this could still be the straight. Oh, this can't have a 3 in it, of course. That is a 2-4 pair. So this can't be a straight anymore, can it? Because it would have to have a 4 in it. So this is the straight. 1s and 1s. 3, 5, 6, and 8. This can't be any of the middle digits because it's and that's got to be the one that it's consecutive to. And no, that's not the same. Or I can't find the other one anyway. 1s aren't here. These cells are from here, here, and here. They can be a bit dim sometimes, cats, admittedly. This certainly isn't 6 or 8. That isn't a 6, and that isn't a 6. So where's 6 in the box? It's down here. That's not 5. That's not 6 and 5. They do like lasers. Oh, one's go up here, so ones aren't in this thingamajig. So 6s are definitely going to go down here with the 5s. Of which at least one of them has to be nearish the outside. But probably not particularly. That's not an 8. 8s are here, so that's not a 7. But it's quite a bit easier once you know the non-consecutive side of things again. That can't be a 6. It can't be a 5 either, thinking about non-consecutive stuff. 7, 8. That's 4 and 5, or 5, 4. 7, 8. Both of those are fine. If that was 1, no, I was worried about it being next to 2s. They're not good on polished floors, that's for certain. Ones. Ones are down here, but sort of knew that already. There's my full house. I got completely confused. 5s and 6s. If that's 3, no, 3, 8, 6, 5 is okay. Yeah, you gotta watch out. They are quite smart. 4s. I mean, 4, 5. We'll put 6 over there, but that's okay. This can't be a 5, 6, of course, because then that would be consecutive. If that were a 1, then that would be 4 and that would be 2. And then where is that 2? It would have to be all the way over here. But that's probably okay. Hey, pause. I'm determined to finish this now, though, having gone back to it. But that's probably not going to do much for me. Oh no! It can't obviously look like that, can it? That's got to be part of the royal flush, as does that, because if your 2 pair looked like this. So that's part of your royal flush and doesn't come from those. These aren't 2s anymore because the 1s. That's also part of your royal flush. That's not a 7. That can't be a 6 or 8 in here. If that can't be a 3 either. So yeah, so if 1, then where does this 2 go? That's definitely a 4. 4, 2, 4. 4s and 3s. That's apparently a 1. There's not part of that, and there's not part, so it's got to be green. So we get a green 2 somewhere here, which sorts this out. That's not 4 and 7 anymore. Apparently that's that way around. That's got to be yellow now. And that does put a 5 and a 6 like this. Not 3. It's not 9. Can't be an 8 because then you'd need a 7 repeated. Certainly not a 1. Oh, if that always takes a 3, doesn't it? Which goes somewhere here or here. Green 2 somewhere there. What else can we do? 1, 2, 7. And what's the last digit? An 8. That can't be a 7. That can't be a 2. That can't be a 2. Yeah, I don't think anyone's accusing you of that, so. I mean, this cell can't be an 8. It's just got to be another non-consecutive that I'm not seeing at this point. That can be 8s. That's not 7. There's a 7. 8's there. That's not 7. Almost made it not an 8. That's not how this puzzle works. Oh, that could be 5 if that's 5. But there's 5, 5, 4 like that. So that's 9 and 3. That's not an 8. 8's here. That's not 7. There's a 7. 1, 8, 2, 8, 1. 6's are up here. There's a 5. 3's and 8's from the row. 8's over here. 6's, 2's and 9's, 3's and 5's. 5 goes over there. That's a yellow 5 and a blue 3. And the 1. 1 sort of stays out. Well, dear Lord. Thank you very much, Nurator, for your message of what to do. That was not doing well, though. But we got it. We persevered. Even though I don't think it particularly counts when you... What am I trying to say? When you ignore half the rules for half the puzzle. That makes things harder. For sure. Very nice. Good puzzle. Enjoyed that once we got there. There we go. Right. Let's go back to this one, shall we? Hopefully I can just bring up the rules again easily. Nice. Right. So we're thinking about if it could start with a 3, weren't we? Because in that case, you're saying that... So your maximum 35... Oh, but as soon as you're anything on the outside, your maximum 32. And 32 doesn't work because then you're running into a problem. But I think you can be 31, can you? And then you've got another sum to 31. You've got your 9, which is 40. No, because that would need another 1. So that doesn't work. So this isn't 3. And that's therefore not 3. And one of these is 3. And is that's exactly the same here, isn't it? That can't be a 3 because you can't be 31. You'd need another 1, and you can't be 32 because you're too much on the outside. So this one's definitely 30 something, and certainly can't be 32 because that's too much on the outside. So that's 1, 2, 1 like that. This has got to sum to 31 somewhere along here. Add another 9. Add another 10, sorry, is 41 and leaves 4 on the outside. And there's a 9 there. So this has a sandwich sum of 31 at that point. I'd get a lot more of them, probably. This is relatively small, so it's going to be a 10 number type thing. And so that puts the 9s not too far down. And of course, no matter what this cell is, like if that's a 5, then these next cells sum to 10. So that's either going to be done in 2 or done in 3 because you've used the 1. So the blue cell goes either there or there, in this case, the 9 in that case. Which might be interesting with these, perhaps. That can't be a 1. Can it be a 9? Oh, it probably can be a 9. So yeah, so this doesn't particularly matter what it is. How about this guy, though? Because he's going to be 20-something. And this is also going to be 20-something, actually, isn't it? Which I hadn't realised. This, for the exact reason as that can't be a 3. So this is 20-something in between your 1 and 9. And you need to sum up in total to... So you probably could be 20. Oh yeah, for sure you can be 21. It's just like a 6, 7, 8, 9. I don't know if the all valid clues are given rule is going to be relevant. That might be a hard thing to like spot the reverse version of it, won't it? If I know you can, because this is 20. Oh, this is 20, like quite a big 20. So that can't be a 1 or a 9 because... Oh, and yeah, sorry. That also can't be a 1 or a 9 because that's the maximum 21. So 1s go somewhere here and 9s go somewhere there in this row. Oh, and the 1s might be interesting with that, actually. Now this is doing something quite big. That has to be at least... because that's at least 23. That's at least 4 cells, and it has to be 4 cells. That's a 1-9 pair like that. And surely this can't be that big. Depending on what this is, it's like what am I trying to say? So you've got 20-something. Call it green. Or call that like an X or something. There we go. See if I can... Oh, I can do that. So you've got 20 add X, add another X, add... Actually, I'll make them colours. I prefer that. That one's green, that one's yellow. So 20 add green is this sum plus another 10, or plus another X, plus another X, which is now green, plus yellow, plus the 10 made up of these two, is going to give you 45. 10 like that. That equals 45, right? So you get 15 is 2 green plus yellow. Which might be interesting. That's not an 8 at least. 2 greens, that can't be a 3. It's not a 4. 2 5s don't work. 2 6s would need a 3, and 2 7s need a 1. So that does have to be 6 and 3. That is the only way that works. 2 3s 9. 2 5s doesn't work, and 2 7s. Yeah. Nice. Good bit of maths. This surely can't be. Oh, can we do the same thing along here? Especially now we've got the 3. Because if that was the 9, then... So let me just cross off that clue is done, and that clue is done. If this cell's 9, then you've got the exact same thing going on here and there, that 2 lots of that plus that is 15. Oh. Damn, sorry. I did, didn't I? Thank you. Is 13. Thank you very much. So 2 3s would need a 7. Oh, is it going to give me multiple options? It is. At least one of those is always 3. So you're 23 and 7, or you're 25 and 3. That seems a bit better. If that's 23, if that's 23, 33, 35, that's a 3 and a 7. Or if that's 25, 35, 37, that's a 5 and a 3. They look a bit better, don't they? Never do algebra on a late Wednesday evening. Never goes well. I was just noticing this, by the way. I'm realizing if that's the 9, then that has to be 5 and 2 3. But I don't know if that particularly helps. And that's left this far more open as well, hasn't it? Unfortunately, that we probably can't do so well with making these 9s or the such. That can be a 9, can't it? 9 and 1. Yeah. Oh, this is interesting, actually. If that is 5, it does have to complete itself with 2 3. Or it sums to 10 across that gap. So that might do something. Maybe. If this is 1, then the 9s go there or there. 25 sum in row 3. 25 with a 2 and a 5. It would need another 3, wouldn't it? Yes. Which can't go here. Oh, that's nice. That is a very good spot. Because you're making 35 in total, and then you've already got the 7, haven't you? So that's not 5, and that makes the 9s. Whoops. 9 goes there. That's pink. That's certainly not 1 anymore. That's a 2. And isn't it the same that can't be like 28 as well? Yeah, that can't be 28 or even 27, surely. Because then you've got 2 and 7 outside, and that's too much. But 26 add 8. Oh, 26 add 8 is 34. So that is a 4 and a 6. Unless I'm going mad, which is entirely possible. 24 add another 6 would need 5 on the outside, which looks like that should work. With one of these two being a 5. So that's either 5, 9, that's either 1, 5. Yeah, that looks about right. Probably. Five, sevens, and eights, which don't actually matter, coming down here. So this 20 clue, it certainly can't be 21, because then that would sum to 21, and that just breaks. So that's 1 somewhere here. If that's 21, if that was a 1, the most this could be is 6, 7, and 8, which is 21. So 1's in fact go there. Annoyingly, don't sort of do any work with this, unfortunately. I mean, this can't be a 9 either at this point, can it? Because that puts 1 somewhere here or here. So that sells at least pink. I don't think it does much. Yeah, it can't, yeah. But we can do the same, well, it is exactly the same maths here, isn't it? That 2 times that cell, add that cell, is 13. So that can be 3 and 7, 4 and 5 in this case. Yeah, that's okay. Double 5 and 3 doesn't work because the 3's there. So you get a weird 3, 5, 7 triple there, which is interesting. And I'll just check that. So 23 in here, 33, 35, yeah, puts 3 and 7. And 24, 34, 40, yeah, 5. Nice. Fives on the outside. That was one with a 1-9 pair there. That's probably fine. Should be 4, not 2. It should be 4, shouldn't it? Thank you. Brain is definitely not working all that well today. One somewhere here. And maybe that does help with this. I was just thinking that if that's 9 there, then you obviously can't have a 1 directly above it because of the 2 clue at the bottom. So that would put something diagonal like this. Oh, 6, yeah, 6 is down here as well. 4's somewhere there. So 3. I suppose if either of these are a 1, does that also help you out? Surely neither of these are a 9. That can't be true. Oh, yeah, no, it probably can with No. If either of these two cells were a 9, then what am I trying to say? Then these couldn't be 1s because these match up. I'm just going to talk about it in one particular column. If that cell's a 9, that couldn't be a 1, because then this would have to add up to more than 10. And it couldn't be a 2 something, because the most that could be at that point is 21 with the 1s up there. And then certainly can't be a 3 either. So I think that has to be a 9. I'm happy to be corrected if I've missed an option there, because it's the same for no matter which, if those are the 9s and that's affecting those, or the other way around, like which one of those two is true. Now I've got a cat that's woken up and wants attention. So you got 9s. Oh, 9s, look. Because as soon as one of these is a 1, you can have a 9 there or there. I wonder if this could be a 2-3 pair. It probably can. I mean, 9 and 1 can't be like that. You definitely have 9s and 1s across from each other. Oh, but if this was a 1, then where is your 9 going? It would have to go all the way up there. So that doesn't work. Does 1 and 9 here work? No, because that's at least 14. So they are a 2-3 pair. Yeah. And the one that's 30 something, for the same reasons that we looked at before, has to have a 1 down here. So that puts the 919 like that. Which doesn't help you here, unfortunately. Means that 1s are there. So this is 31, which needs 4 on the outside, doesn't it? Oh god, have I broken it? No. If it was 31, it would have 4 on the outside. Oh, what is my... I can't tell what I'm doing at this point. And I've done something wrong. I think it's that 4. Or it's the 1s. No, those the 1s. Presumably. Yeah. So why did I think... Oh, yeah, of course. Sorry. Thank you. That's 1. Yeah, and that could be 1 and 9, can't it? And then you're absolutely fine. Yeah. Don't know why I was trying to minimize it. Went the wrong way. So, if neither of these were 1, then one of them is 30 something, which would have to be 31 with a 4 up here. So I'm slightly using the fact of where I went wrong and broke it. I'm happy that one of those two is a 1. And that's going to put a 9 all the way up here. Which, if it was the 9 and 1, if that was the one with the 9 up there, that doesn't work, because that at least does have a minimum of 2, 3, 4, 5, 6, which is 20. So this is your 1. And the 9s therefore do go there. Blue, pink, blue, pink, 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 pink. Blue 1 in the middle. 9 somewhere like that. Nice. So surely that can't be 9 here, because that would be 29 there, 39. No, that does work with a 6 at the top, actually, doesn't it? That's not a 5. This point. Yeah, 29 works for 6, or your 9 up there. Oh, in which case, yeah, either way, that can't be 30 something. That is a 2. Which was just a corollary from getting the 1s in there, wasn't it? Of having that 4. It's definitely 1 and 2. So if these two were your cells, that would be at most 20. At most 26. If that's 9, that's at most 5, 6, 7, 8. So that comes from there. 9 somewhere here. And is it worth doing the algebra on... I want that to be green. On this column? Where... See if I can do it right. 10 plus green is the sandwich. Plus the actual sandwich crust is another 10. Plus the green cell again. Plus these two. Plus yellow. That's 45, isn't it? So you get the 2 green add yellow is 25. So green's got to be relatively big. Because yellow has a maximum of 15. So green's going to be at least 5. And I mean, if that was a 4, this has a maximum of 12. That would have to be at least 7 or 8. Yeah, I don't think that does work. If that's 4... Oh, no, you could be double. 4, double 8, and 5 is fine. Yeah. 7, no, 15. Yeah, at least 5. Yeah, also because of what I was on about with 14s earlier. I kind of wanted the 5 on this side, because then that would give you a 3, 7, wouldn't it? This cell can't be a 1, can it? Because then your sandwich would be this digit, which actually has to be that digit. So 1s go somewhere over here, and they also can't go there, because then that would be 2, 3, 4 as a minimum. So these two sum to that, and that's at least a 5, 6, 7, 8. They sort of come from this. And then they don't have a 6 in them either. That's not a 2. So if that's 9, that had to be 6 up there. Gives you these pair of 6s. But I could see that happening, sort of thing. This now should be interesting, because that's certainly not a 9 because this is a single digit sandwich sum. There's a 9 there. 6, 7, and 8. 9s aren't there. 9s aren't there either. That's got to be 9 down here. Whoops. 9 and 1 and 9. And these two sum to 9 without using 4 and 5. And there's 6s up here. So you get it looking like that. 7s are there. 3, 6, and 8. What are these two cells? 3s and 4s? 2 down here. 2 down here means that is either a 7 or 8 with a 3 there. 3, 5, 8, 1, 4, 6. 1's at the top. Oh, 9s. 9s now go here, which I wasn't expecting. Thought they'd be at the bottom. There's a blue 9. There's my last blue 1. Lovely. Right. How about this then? That can still be... No, it can't be 26 because 26 needs 8765. And 25 would need 876. Oh, 8764 works. If that's a 5. I suspect that might be how it goes. 2s and 7s and 2s. There's a 2-4 pair. If that is 3-4... no. I was thinking it might do something with these sort of things. 3-4 pair in this row, though. Also, it doesn't look like it does much. Oh. At least it's the sort of puzzle where there's 3s here that go down there. I've forgotten which way around this now goes. But you have quite a lot of options to do. 1, 2, 4 triple ever since you solved the row 3. Oh, was there? Oh. Oh, whoops. Sorry about that. 5, not a row 9, column 5. Remaining digit. The column is 3. Sorry, John, I don't understand. Other John. Oh yeah, because it would put a 3 at the top there, wouldn't it? Yes. Yeah. Sorry. I get what you mean now. Nice. There's a 6 and 8. I've completely forgotten which way around this has to do. That surely can't be a 23. That's got to be 20, 24, 34 with 11 more. Yeah. So this is now a 3-4 pair with a 7. 3, 6, and 8. Not 3s. 3s at the top there. There's a 5. 3s and 4s. 3-4 pair here means that's 3. Oh, 7. 7s and 3s. 7s and 7s and 7s. Sum to 17? Probably. 2 times that plus these 2. Oh, so this can't be 5 anymore. Because this is now way too small. 5s in column 2. Thank you. So 2 times green add this. And this now has a maximum of 12. So greens, 2 times green is at least 13. So that can't be 6 either. So if it was 7, that would be 14, and these would have to sum to 11. With 4 and 7s, that doesn't work. That is 8. Double that is 16. That leaves 9 left. So that's 5 or 7. Those two sum to 9. Ah, 3 still have a couple of places. Is it going to be the negative constraint? I suspect. It's all done. That's all done. That's all done. That one's done. It's not quite done. Oh no, we've still got stuff we can do here, can't we? So 23, 33, 38 would put a 7. And 24, 34, 40 would put a 5. So you get a 5-7 pair there. These sum to 9. Oops. Is that a quad? Yes, it is, isn't it? There's a 7 here. Whoa, that's a few too many 7s. 4, 5, 6. Are you really going to make us search for a negative constraint at this point, Chad? Feels a bit cruel. Or am I missing some straightforward Sudoku? Which is very, very likely. That sums to 9. So 4, 4, 5, 3. Would put 2, and then a 6 and a 7. Sorry, 4, 4, 5, 3. Hey, that's not 8. I think that was what I was not missing. 4, 5, 3, 2, 7, 6. Or 2, 7, 5, 6, 3, 4. Right. Where's a straightforward negative constraint? Let's sort of think about what the rows and columns. Like this column isn't going to do anything with what the sandwich sum is, and neither's that. This can't be a sandwich sum from the bottom. Oh yeah, I suppose as soon as you got one clue, you can't have another one, can you? That's certainly not. Yeah, this can't have a clue here. That can't have a clue there. Can't have a clue here. That's not something to 39 or 46 or anything. This is a clue of 17. So it'll be the horizontals, possibly. That's not helping us out. It's not helping us out. This one. No, that's not helping us out. And certainly not sum of 93, and that one doesn't help. Where's the negative constraint? I think I've checked them all. It feels like something you would, or unless it's a red herring. Could be a 1-digit thing. Oh, here. Yeah, if that's 6, that couldn't be 8. Or if that's 3, that couldn't be 5. So this one looks suspicious. And that's the only one, isn't it? Yeah, sorry, I had thought about single digits and then forgot. Probably, but I'm pretty sure this is the only row that would be a problem. No, this one as well could be an issue with a 2, 6 and an 8 there. Row 2 and row 7 only, yes, yeah. So how do you find out? If that's 6, that's 3, that's 5, that's 8. So you don't have to worry about this being a 6. 5 is in row 7, column 9. That's nice, yes. Yeah, that would put a 3 there, wouldn't it? And I think row 7 is now okay, because that's only problematic if that's a 6. But if that's a 6, that's a 4, 5 pair, 3, 5, 8, 3. So this one's now okay. So it's just going to be this one. Which is quite the long... Oh god, yeah. Sorry. I'm not with it. That's 6, 6 would put 8 there, which is probably fine. The other thing I want to do, if I can ever work out which colours I want to use, is do a bit of this. I don't know how useful it will be. So if that was 5... Yeah, if that's 5, that's 6, 4. Oh no, 5 there's okay. Because 6, 4, 3 doesn't matter with this. 6 and 4 is a problem as well, isn't it? Which I hadn't realised. So I think this can't be 4, because if you're 4, let's put in what this can be. If this is 4, that's 2, 7, 5, 3, 6. Oh, that is okay. This so can't be 5, because then that's 2, 7, and that cell has no fill. So if this is 3, then that's 5. Is that 5 and the row either goes here or here. I suppose 5, 5, 4, 6, 8, 3. That's okay. What we need to do as well is work out a relationship between this cell and what's going on at the top, I think. Because if that's 3, 23... If that's 23, I'm just going to have to add it up because I can't work out otherwise. 33, 38, that's 7. The one that would be an issue is if that's 275, which puts 4 here and 3 there. As in an issue with this row. Because if that's 2, that's got to be 6. Which puts 8 there. And that breaks this. I mean, that's not very nice, is it? I think. 2, 7, 5, 3. 2, 2, 7, 5. That's 4, 3. And then both these two cells have to be 8. Is that the intentional route? Six, 5, 8. Surely you've given us something nicer to spot than that. With the 6, 8 chain. I'm so bad at once I've seen something. And I'll just put it in to make sure that it is true. Yeah, these two would both be 8s. Once I've seen something, then I find it's harder to look somewhere else. So you must be able to say something about I mean, is it possible to rule it out without using both row 2 and row 7? That is like an actual question to you, Chad. Or do you have to use both of those? You can get away with just one. So, because I mean, if that's 8, then orange is 6. That 8 there. If 6 Then orange is 8. And is 6, 3, 8, 4. 4s and 4s. I'm afraid I'm close but no cigar. 8. Anyway, which said that's not 2. 4, 4, 3, 6. So that can't be 8. So yeah, so if this is an 8, which I think is how it doesn't work, so I should be able to rule it out, then 8, 8, 3, 4, 4, 6, 5, 8, 8, 3, 4. Man. 8, 8, 3, 4, because that's not allowed to be 6. That's 3, 5, 8. 8, 5. 8, 3, 4, 3, 5, 6, 4, 6. 6, 5, 4. I feel like I've looked at everything done. I suppose I haven't. If 8. But I can't see any of yellow and orange actually looking down. If that's 8, then orange is 6, and therefore that's not 6 anyway. I'm afraid I just can't see it. If I was solving it on my own, I'd use my thing up here. But I would be curious of the intended solution at this point, and I'll then I can spell it, and then no, I can spell it, then I can see how it works. If row 7, column 1 was a 6. 6 going box 8, 6 and 6. Oh, well, that's a bit more straightforward, isn't it? Because that sees both of those. Yeah, I should have seen that. So that's now 5 or 8. And if that's 3, that's then 8, and then that's 5, and that doesn't work. So that has to be 3 down here. Right. Yes, that is a bit more of a straightforward thing to spot, to be fair. Orange is 8. That's a 6, so this can't be has to be 4 and 2. That way round is here 6 here. 8 and 4, 4 and 5, and 8, 7 and 8 and 5 and 2, 5 and 7, 7 and 6. Nice. Sorry about that at the end there. We got there though. Just took a little while. A very nice puzzle. Pleased to have solved it. It was a bit harsh putting in negative stuff. Did you try and set it with putting in all the clues? And if you could sort out because obviously there's some sort of pattern, isn't there, at the end, that if you then said this was like a 1 clue with an 8 and a 6 too, I wonder if it would then work. Ah, fair. Yeah. It's the sort of thing where I can imagine it being tricky to have a puzzle like that, yeah. And to be fair, the negative step of if I did look in the right place would have been easier to spot. Nice. Very nice. For the puzzle. That's been on my list to solve for quite a while, by the way. So I'm pleased we got around to it. Very good. Right, I need to go grab myself a drink. So I'll go do that. But I'll be back in like a minute or so. And then what's next on the list? Need to update the list as well. Malrog puzzle. Cherry Blossom. Oh yes. I think I vaguely remember this one. Let's go. Oh, I forget that those cameras turn up on that one. There is a cat at least. But anyway, yeah, I'll go grab a drink. I'll be back in a minute. We are muted. We are. Great success. Oh, I need to do puzzles and such. I had to take a bit longer because the cats were yelling for food. Whoa. 36, will that work? That'll do. Actually, let's make it a bit more readable. Nice. You could only put 2 2s up top. Yeah. You can never have more than 3 2s in a row or column, can you? It's a very fun idea, I have to say. I had thought when I first read it, I thought they were going to be indexing. So I thought this was going to be, or like take this row for example. I thought that was going to be indexing that cell and that indexing that cell, and then you read that as the clue. And I was wondering how on earth you start the puzzle like that. Don't want to give anyone any ideas. Right. So yeah, so puzzle by Malrog. No. Standard Sudoku. And standard white dots and quad clues. Then these purple dots are pivot points for any clues touching their cell, which are rotated clockwise through the point 90 degrees, where n is the value of the pivot. Interesting. So our quad doesn't actually necessarily sit there. Could sit somewhere here, here, or here instead. And this one, because this one can never rotate outside the grid, every other position that's rotated, it would. No, it could sit up here as well, couldn't it? Interesting. So I suppose this is either a factor of like a modularity of 3 or 4, mod 4, because once you're mod 4, you're rotated back to yourself, aren't you? So that could be 3, 4, 7, or 8, and that's it's clockwise, isn't it? I assume. Yeah, that's almost the same here, except it's 1 and 4, 1 and 0 mod 4, 5 and 8. And none of these cells can be 1, 5, or 9, which 1, 5, and 9 are at least interesting because they're the same mod 4. It's like this clue here is never rotated too much. I've just noticed that this guy doesn't actually move because the white dots can move as well, is my understanding. I rather like the look of some of these that is just a quad 3 spinning around in its box and doing absolutely nothing until it's needed, presumably. And it's weird because some of these you'll actually take them outside, like they're not necessarily contained within a box anymore, are they? If this is 3 or 7, yeah, this has surely got to help us out because of the quad. Because this, I mean, this quad could be rotated to here, here. Oh no, it can't because it's not 1, 5, or 9. It never sits there. So the only way that would be a 3 or 7 is if this is rotated 180 degrees down to here. So this would have to be a 2 or a 6 if that is 3 or 7. Oh, 1, 5s, and 9s at this point, because they're not there. Either go like this, which doesn't work, does it? Because of the white dot. Right, there we go, there's something. So this does have to be flipped up here, which makes this a 3 or a 7, and puts 1, 5, 9 there, else you'd have 1, 5, and 9 on a white dot. Therefore, this does have to be rotated outside the grid. So that's going to be a 3 and 7. No. That has to be a 2 or 6, sorry. With the 3s and 7s. So that clue then rotates down to here. And oh no, I thought that once this was 1, 5, or 9, you'd have a problem with too many 1, 5, 9s in the row. That actually looks okay. If this is 1 or 5 and it has rotated that quad up to these 4 cells, then because of these two, that's definitely 1, 5, and 9. Or this is 4 and 8, and therefore that's 1, 5, or 9 anyway. Trying to think if I can show this as this has got to have the last odd digit because it's just a normal white dot, and therefore these are all even. 2, 4, 6, 8, and your 3, 7 does sit outside the grid there. And yeah, this could basically be whatever it wants, as long as it's got 1 of 3 and 7. Up here, the 4s and 8s. Oh, this can't be rotated up, because if this is rotated up to those 4 cells, then that would have to be a 1, 5, 9 triple, but we already got a 1 and 7. So that's a 4 and 8 with a 1, 5, 9 like this. this 4 and 8 means that can't be 4 and 8, or else this would just be back to where it was. It also can't. It also can't be a 159, which it certainly can't be. So this is rotated either like that or like this, and at least one of the outside cells are 4 and 8. The white dot also could be rotated. Well, in fact, it has to be rotated, doesn't it? It either sits here or here. Yeah. That's not 3 and 7, look. This is a 2-6, which is a 180-degree rotation. So this is now a white dot. So that's 3, 5, or 7. Oh, it's a 3, 7. Because your white dot's rotated around this purple cell. Because I was thinking that stops that being a 4 and 8, but it actually doesn't. So it's cruel. There's a virtual 3-7 pair there happening. So 3s and 7s go up here in this box. So this, yeah, this rotates like that, but that could be a 4-8 pair, I think. Can't see any real reason why it shouldn't be. Stakes 1 of 159, and yeah, I was trying to work out if I could, how best to do so. And couldn't particularly think of a way. Like, what I really want to be able to do is put a little cross in the middle. Yeah, something like that. That's probably fine, isn't it? Call that one pink. Depends if this thing gets incredibly confusing. That green goes up here. Should probably stick with just greens and blues. I can leave the 159 as is. Or I can just make it green. Oh, I could green it and then cross it. Yeah, that probably is worth doing, isn't it? Because you can hide 4s and 6s there. And what I'll do is I'll just mark real. I'll mark a real white dot with an X. So in fact, that one's real, and that one's real, and that one's real. Progress. Vaguely. So if this was a 4-8 pair, which happens if this is 2 or 6, that's probably all fine. Yeah. And clues are allowed to overlap, aren't they? Yeah, rotated clues may overlap. So is it this cell? This clue? Because it feels like a lot of everything else is just incredibly open as to what they could be. I mean, that could still be an 8 with a 2, 3, 4. It's not really having an effect of anything up there. There'll be an 8 looking at a 4. that should be fine. And if this was 1 and 5, it's, oh no, it's not quite the same thing. I wanted to pence mark this, but that could be a 4 with a 2-3 down here. Because if this is 1 or 5, oh, this might have an interesting effect on that actually. If that's 1 or 5 with the 2-3-4, then this quad either sits there or sits there, which has lots of options of how it works. Yeah, this clue specifically works rotating 270 degrees. Because it would be something like 5, 3, 7 there. It's sort of interesting that the white dot sits opposite it, maybe. Oh, I don't know. One fives, nines are basically done all they're gonna do. So the 1s and 5s don't particularly see each other much at that point. And I want to say something about these evens looking down into this, but again, I really don't think I can. Unless it does something sort of all the way along. Just checking that there wasn't some weird rule about quads only allowed to appear once. But it is just standard quad stuff. This 4-8 has to appear in this quad. So that sells for an 8, which gives you a 159 there. And now does something interesting with this, because this can't rotate 270 degrees anymore. So that rules out 3s and 7s from here. Okay. Is that right where I want to put my mouse cat? It's left me about an inch of mouse mat left. Because it can't rotate through 270, because then it would be sat like this, and then these two are a problem. So if it stayed where it was, then this would be a 3-5-7 triple, which forces a 3-5-7 like that. So that's probably okay. If it's rotated once, which is a 1. Hang on, I've got rid of the wrong things. Haven't I? No, 3s and 7s are. Yeah, 1-5-9 is a rotate once, isn't it? Row 5, column 6. Always 3 or 7. Couldn't you? Oh, no, because of the white dot again. Yeah. I thought you could hide the 5 there and then put a 3-7 like this. And in fact, you can't be 90 degree, 180 either, can you? Because that puts 2 or 6 there, and then you got too many evens. So you either stay where you are, which puts that at 3-7, or you move around once, which again, as you say, makes that a 3 or 7. Nice. And if you do rotate round once, this can't be a 1 or a 9 even. That would have to be a 5. Is that an extra revelation, or are you just pleased that I've managed to catch up with where you were? But yes, that is. So 5, that's something like a 3-7 there, or that's 4 and 8, and then 5-7 like this, which at least makes the 2-4-6 not allowed to rotate round by 1. Still has various options. Oh, this can be a 5, because that would be a 5 and a 4 at that point, wouldn't it? I was just looking at this white dot. But if that is 5, no, because then one of these has to be 3-7. Or I was thinking if that's 4 and 8, then that's 3, 5, 7, or 9. Because this white dot would be rotated 360 degrees. If this is 4 and 8, it repeats over there because it needs to go on the X. It was a good shout, pen tooling this. It would have to go on the X there. I might also cross off that. As in that's not a real white dot, because that was confusing me as well. So grey crosses are real white dots. Red crosses are fake ones. So yeah, so 5-4. And then with a 3-7, 1-3-7 somewhere here or here. This clue can't be 3 or 7, which are the two 270 degree options. So that might help. And if you're rotated once, which is a 1-5-9, it would put 1s and 5s in there and make that a 4-8. Does that do anything? Possibly. But probably not. I keep coming back to this white dot, but it's basically not doing much because it can go either way round. And I think that's true for this guy as well. If that's 5, then you've used all of 5, 3, and 7, and then that wouldn't be a 1-5-9. Yeah. And if this is 4 and 8, then you have a 3-5-7 there. And does that hurt this? No, because that could be like a 6 with 2s and 4s at the top. Four and 8 does at least, like, if that's an 8, that would have to be 8, 7, and 6. Row 3, columns 6 and 7. Oh, it does. Yes, there's a virtual 4-8 pair. That was probably there for a very long time. Thank you. So that's not a real red dot. And gonna have to do something else with my mouse. Hang on. Yeah. There we go, that works. And this is a real wet right dot. Nice, there's an 8 at the top, 4 at the top there. This is rotated around once, so there's a virtual 3, 7. This isn't 1, 5, or 9 anymore because of the 5. Lovely. Very good spot. There's a 4 in here. And this one, which we're going to call green, is rotated into there. So that's all your 3s and 7s accounted for in this box. Nice. So this is either 180 degrees with 5 somewhere here, or it appears to be 0 degrees with 5 somewhere there. Both of which are probably fine. This takes 3, 7, and then 1 even, but I really want the pen to mark all of that. But 1s and 9s are on the outside here, which might help. And this, I mean, this 5 sort of knifing into this clue, and similarly with the 4. Feels like it should get some work done. This isn't 4, by the way. Oh, this isn't 4. So this has to be a 2, 3, 4 there. Because either you're rotated up there, or you stay as you are, but that's an 8. Column 7, 8, 9. Oh, does it do work on this guy, do you reckon, as well? I suppose 4s either go like there and there, don't they? Because the 4 that's collected by this quad has to go somewhere up and down there. So this can't be 180 degrees anymore, which is your 2, 6 option. And it's certainly not a 4. There's a 1, 5, 9. A 3, 7, 8 at the top there. So if this was rotated 270, which is 3 or 7, it really is, isn't it? Malrog is a damn good setter, to be fair. If this was rotated 270, that would have to be 3. Is it? Oh no, 3 or 7. And then that would be 4, 2, 6. Probably okay. I mean, 4. 4. I can rule out a 3 from here. I'm not sure if it's the most pleasant. I'm gonna do it to get some. So I feel like I've done something. If that's 3, the 2, 4, 6 sits down there, and it has to be 4, 2, 6. What did I think? And as soon as that's 4, this one's got to be rotated up. So that would have to be 3 and 2 like that. Which breaks the 3 in this cell. And I doubt that actually does anything. Which is why I'll allow myself to have it. I keep on wanting to have these 3s and these 3s interact. But they don't. It's cruel. 2, 6 pair means that this can't be rotated 0 and it can't be rotated 1, which is 1, 5, or 9. So it is a 7. It is down here, which I'll put the 3 back for now, because we can do this and we can say that that's rotated by 1, and then that would be a 2-3 pair and one of them is a 3. So that's the sort of way you're probably actually meant to do it. So this guy, which I'll make blue, is turned into down here. So that's got to be a 2 and a 6 like that. That surely looks up, doesn't it? A bit, not much. Oh, not as much as I thought. And this chap here, which is going to be pink, is sat like that. Nice. 5s are there. What's left? 1, 3, 8, 9. Leaving 2 and 6 at the bottom. Lovely. No 5s. Yeah, no 5s seem okay. Shimmied this up here, haven't I? Yeah. So this could be rotated down here with 5s there, which would put a 1, because of this 1, 5, would put a 1 there, which might do something. Yeah, it puts 5 here and 1 there because of this 1, 5, 9. I'd put good money on that being the answer. 5, 6, 2, 8, 6, 7. It does a lot of work. So why couldn't this? Oh, C's 2 and 4. Oh no, they can still be either way. So if this wasn't rotated, this would be an 8. And does that break for some reason? 8s would put 5s there. That's 7 looks across at the 3, and this needs to have a 7 on it. So there's 7, and then there's an 8, and then there's a 6. That's how you get that one to rotate round. Let's make that pink. Put in where it is. So the 5s at this point have to go here. Because we've got the 5 already. That sees the 1, which means the 1 is there. Which does that, which does this. Which, because of the 4, does this. 2, 8, 6, 7, 3, 7, 3. 2s and 6s sorts those ones out as well. And I think that was about as far as I'd seen at that point. 2 9s and 4s. There's a 9. 2, 4. Awesome. Very cool puzzle. This needs an odd digit because it's a real white dot, and the only one left is a 3, which actually has to go down there. It certainly is, isn't it? Would not appreciate it if I started attempting to sing, though. So that definitely will never happen on stream. There's a 1 top, 8s and 9s. 1, 2, 6, 7, probably. Looks like it, doesn't it? 3s are at the bottom now, so this either rotates 180 or 270. 180 is 2, 6, 2 or 6, or 3, 7. It's not 6 or 3. So this is a fake white dot, which I'll cross off. That either goes there, which would put 2, 1, or there with a 7, 8. That's nice that that still can happen either way. Right. Oh, ones look up here, of course. I thought that should have been sorted out. I just haven't looked in a while, I think. 7s and 5s 4s, 8s, and 9s. Nice. Sixes are at the top. But we don't particularly know where 5s go. But again, this can't be rotated 180, so that's not a 2. It can't be rotated 1, so that's not a 5 and 9. This is a 4, 4 and 2. So this stays as it is with 5s there and 6s somewhere here or here. 3, 5, 7, 8 and 3. 6 and 1, so 9s. Been the easier thing to put in there. 9s and 5s. 2, 6, 7. Triple. That's about right, doesn't it? 5, 8 and 3. Where's my 3s? There's my 3s. So this now has to be rotated 180. Let's try that again. So our white dot looks like that. Let's do our last. I should have done that so I didn't have to change colour. White dot there, so that's a 1, 2, 6, 1. 9s? Yeah. 9s, 8, 4s. God, I can't see. 7, 7s, 4s. 7s. There we go. 2s and 6s, 7s and 6s, 1s, 6s and 2s. That was very cool. I haven't done this one, have I? Let's make that blue. That was a very awesome puzzle. A very good idea and incredibly well executed as well. I can't remember what, or if it's had many solves and such. It is a, yeah, it's a, because it's a puzzle from, a while ago, so I'm sure it's published. But yeah. Very cool puzzle, Malrog. Thank you for that one. Nice. Right. What have we got next on the old list? Oh yeah. I think at this point I was having a look earlier. Of puzzles that look like they might be fun. And this one certainly looked like it should be. Save that, back to that. Shorter rule set on this one. Go, oh, that's a bit too big. 60. There we go. So now I'll put his head exactly where I want to. Got my mouse here. Think I can get the rest of your head like that. That'll work. Vaguely. So normal Sudoku, normal arrow, and double mark diagonal. And I was just wondering if it uses the Fistum of L trick, but I don't think there's anything looking in there, so probably not. Whoops. He is, exactly. So obviously these are all going to be different on their various x's, and this, oh, that cell can be green still. Thinking that couldn't be a 6, 7, 8, 9. These, they could be as small as 3 if the other one was a 9. It's interesting that this and, I suppose, this and this doesn't match up symmetry because those two do. Oh, is it? Can you use the exploded ring on this? Which I can never remember, so I'm just going to draw out. something like this, isn't it? And then blues there. Blues, 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 blues. Cancel blues and pinks. Then turn those into normal. So yeah, so those cancel. And then you're left with blue equals pink in terms of sum. But oh, and pink in this case has a maximum of 30. Can we say... Can it be... Yeah, no, it can be 30, can't it? I'm pretty sure. Yeah. Because these work with 1s, 2s there, don't they? No. 1, 2, 3, 4, and 1s and 2s don't work because of the diagonal thing as well. Because if you were 26, like top and bottom would be 1, 2, 3, 4, and then you'd have 1, 2s here, but that puts only 3s and 4s in the corner. But the corners are all different. And is it exactly 4? I mean, it feels like it should be. If you ever had a repeat in any of these, it would have to go there and there. And then I think the problem is that doesn't go in the 4 corners. Is that why the sum does what it does? Because I think we can't immediately just say that the diagonals add 4 without okay, unless you can see something that I just can't, which is yeah, very likely. So if those two repeated, because I wonder if because we're starting off with the minimum looking like that, but that doesn't work because they're diagonals. But sorry, I can't immediately see it. Minimum is putting 3, 4 in the corner. Yeah, but what if this is a 1, 2, 3, 4? Is what I'm wondering about. Because there's no real reason why this shouldn't be allowed to be 1, 2, 3, 4. What it does mean is the edges gain. Yes, yeah, because 1 now the minimum of these is 20, isn't it? Yeah. In fact, because I'm trying to find sets that sum to 20, that's like 1, or sum to 10, that's one that sums to 10. And then I think that's sort of a similar one that sums to 10 as well. Sort of. But I'm willing to accept the fact that there is a maximum of 30. So you get more 6, 7, 8, 9s on all the diagonals as well. So our 6, 7, 8, 9 in the middle sits somewhere like that. Doing something like this as well. And that's a 1, 2, 3. That's a 1, 2, 3. So 5 somewhere like there. And 5s are on this diagonal, aren't they? But you can actually lose your degrees of freedom in those couple of ways, can't you? That it's either 3, 4, 5, 6 in the corners with a whole bunch of 1, 2s, or all of blue cells are 1, 2, 3, 4. And I have realised now that with the actual cancellation that we did, if I just put back the, well, yeah, that one, the Fistmafel ring, then because the pink 6789 and the blue 6789, they're both a set of 6789. So you can cancel it like this, can't you? So the digits around here are exactly the digits on these. But you can have, because I was wondering if it's decreasing the corner by 1 increases the edges by 2. Sorry, I'm just going to put in some numbers. Does this sort of setup not work? Oh, I've got a pair of 4s. On this diagonal. So probably, yeah. No, you are right, aren't you? It does have to be 3, 4, 5, 6. Although, again, I just don't have my head completely around it. But it's only... No, wait, it can't, because these come from 1, 2, 3, 4, 5. So there must be a way of making it not 3, 4, 5, 6. But I think you are right that these can't be 1, 2, 3, 4. But perhaps I just didn't actually check the options. Works the same either way. Ah, okay, right, yeah. Just wanted to go back to doing this to think about these two maybe. Because if that's yellow, that would have to be blue, but that's probably fine. That probably doesn't actually do all that much. Not yet, anyway. Surely, oh, these do have to be. Do they have to be a 6, 7, and then a 8, 9? No, you can be an 8. Wait, if that's 8, 9, 1, that breaks here, doesn't it? Because that would be 6, 7, and 1. So they're not 8s. And the 7 can't pair with a 9. 7's got to pair with a. That's got to be a 1, 3 pair, basically. Sorry, I didn't explain that at all, but I think it sort of makes sense. Sort of. With how those sums work. Because, yeah, couldn't have an 8 on it. 8 and 1 would put another 1. So you get the 6, 7, and then the 7 can't pair with a 9 because then they'd both need 2s. Yeah. 1, 3, 1, 3. 2, 4, 5 triple means this is a 1, 3. Now you got 1s and 3s in the corners. So what does that mean? Is that... oh no. I thought it had to be this all. But it's that one or that one, isn't it? I don't think we've created any quads yet. Can there really be a 6 in either pink or blue? With a 6, 1, 2 and a 9, it feels unlikely. But probably is okay. Um, hmm. I'm having flashbacks, by the way. I've seen a puzzle with this sort of setup before. And remember getting as confused as exactly how the edges all work and the such with that one as well. I mean, I suspect this has to be a 5. Feels like it should be. Do we know where this cell goes? Not particularly. And there might be able to be a bit more set tricks that you can do with all the sums, potentially. That can't be 6 because of this 1, 2, 3. Can we do that anywhere else? Doesn't look like it. And that because any 3-cell arrow needs 2 1, 2, 3s. So you get a virtual 1, 2, 3 triple there. And can you do anything about the fact that this has to go there? It feels like it's not allowed here, is it? If those two repeat, then this cell is the sum of them. Yeah, so that cell goes there. Which probably does nothing. Oh, no, where's it on this diagonal? It's got to go here now. So those 3 are the same. And then this box. Yeah, you can't go there, can you? Definitely go here or here. And now we know. I feel like I should just be able to now we've got that and that being the same, surely it just all clicks together, doesn't it? How's this still holding out? Yellow and blue, yellow and blue. It's pink or blue. This cell, this cell's pink, so that is blue. Because of this diagonal. And that means... Does that not have any follow-up? I mean, pink. Pink somewhere here. These aren't... They come from 1, 2, 3, 4, 5. Whoa. I need to open that up. Spoiling all my cheats. There's 8, 9 at the top there. Top and bottom. Stuff that's left in the middle. Pink there and there. Oh, this is yellow and green as well, of course. And repeat somewhere over there. So if it was green, it would go there. And if it's yellow, it also goes here. Because it can't go there. blue. Oh, blue in this box, nice. Oh, no, wait, sorry, blue where? Or have I missed an option? Is that what you're saying, sorry? Basically finish blue. Blue's there or there. Oh, blue's down here, so this is blue. Nice. And yellow and blues are there. Blue, in fact, is here, of course, isn't it? Sorry, I keep on forgetting about 7, 8, 9's not allowed to be on here. So blue also isn't 6. So 6 is either there or here. So either yellow or pink is 6. Yellow, green. That can still be pink, can't it? That's pink down there. Pink would be 6 or 7, but it seems quite likely. Green isn't 6. Can yellow really be 9? Probably, to be fair. Oh, that's not blue. Blue's here or here. This 8 9 could be that one if it wanted to. Any more 1, 2, 3s that we can do similar colouring with, I wonder? Like the fact that the 2, 4, 5s, this either goes there, which doesn't mean that much, or it goes up here, which also doesn't mean that much. Neither of these can be a 6, because pink or yellow is 6, and none of those can be a 6. But I think these ones can. No, because if that was 1, 2, 6, that would be 3, and then that breaks that. So the only way you'd ever have a 6 on these cells, which are the same as the sort of explodey doodad malarkey, would be that. I'll finish train of thought. Would be a 6 up here. There we go. We got there. That would have to be a 6, 1, 2 with a blue 9. 6, 1, 2 and blue 9 seems quite likely, really. If that's 7, then that's 9. If that's 8, like if yellow was 9, then surely this is a problem. Yeah, because this sums to at least 16, doesn't it? Because that's at least 10 plus 6. So one of those two isn't 9. Yellow's not 9. And that surely can't be 8, no. Tidies this up a bit. So if that's 7, 6, 1, and 2, 3, 4, yeah. One of these, if that one's the 9, then blue's a 9 there. Green's an 8. No, not necessarily. Not necessarily. Yellow could be 8 still. Ah. Pink at the bottom here. I mean, I feel like this has to be pink, doesn't it? Pink goes there or there. That be pink? With pinks here, and no, pink isn't 8, is it? So yeah, in fact, pink goes here or here. It's one of those two, and blue's somewhere there. Yeah, so if this is yellow, it's 8, and therefore it pairs with a 7, and so if this is yellow, that's blue, and that's green. Yellow, blue, green. Sorry, yellow 8. That's a 7, so that's pink. No, that would be blue, green, either which way around. That's 8. Hmm. It's going to be my prediction is there's one more bit of colour in that once we get it, everything falls into place. Green's somewhere up here. So if green's 9, then that's green. Yeah. So wait, yellow? That does at least affect 1s and 3s as well. But that should all be fine, really. There it is. Twos, 4s, and 5s. Like if this is a 2, then that. Yeah, if this is a 2, that has to be an 8, doesn't it? Which. This is a 7-9 with a 6. Yeah, and that all just works. Losing it. Green's up here. Do I really want to mark that? Why is this not doing more? This looks down here. It can't be that. Oh yeah, which I kind of knew. If it were 1s, then that's a 2, 3, 4, 9, and that's a 1. I really don't want that many pencil marks here. 7s, 8s, 9s. 6 and 3 at the top there. Again, I don't think it does much. 8s and 9s in this. Oh no, they can go here. If the 8 and 9, if that was 7. Yeah, 7, 8, 9. I suppose it's because literally all the rotational symmetry works. It is just things like this and this that are going to actually sort anything out. But where they sort them out, I am just not seeing at the moment. That's also got a 2 on it. Let's pencil mark that in. If can't use, so there's the thing about if this cell, well, this is the only digit that sorry, if there's a cell not on the fist and the foul ring, it has to go in the center with a in a diagonal Sudoku. So Are there any digits that you're struggling to get on this though? I can't see any. Like, I was wondering if that stops anything. I suppose ones. Ah, here it is. The 9 does have to be 2, because if these are all ones, then 1 isn't on the ring, and 1 would have to go in the middle. So whichever one is a 9 does look like 2, 3, 4. It straight up has to be 2, 3, 4. Also, I've noticed these aren't ones because that's problematic there. So one of these two is 9 with a 2, 3, 4, which means there aren't any 6s on the explodey ringy doodad. So I can put back some 1, 2, 3, 4, 5s here. Jumping around the grid like that. I think the set will sort of keep coming back in and helping us out a bit occasionally, basically. And it's a bit. I'll use orange. Because we know this sums to 30, don't we? So I was wondering if like that couldn't be a 2. The 4-5 pair on the outside. That's probably completely fine. If this is 9, that's 1. Ooh, and that looks down here. So if blue's but if blue's 9, that's 9. If instead green is 9, then that's a 1. And that's a 1. If green is 9. Blue is 8. If blue is 8, blue goes here. And green does go there, there, and there. So blue, blue, blue. Blue 8s pair with a 7 and a 1. You've got a 1 either here or here. Because either that's 9 and that's 1, or that's 9, and therefore that's 8, 7, and 1. So 1s are there. And one of these two is a 1, 2, 3, but even looking down, they're not really doing much. This cell up here. And if this was other... Oh, no. We know this can't be 2, 3, or 4, because one of these is a 2, 3, 4. So that comes from 5, 6, or 7. So either it's a 5 and then the central digit is 5, which is what I bet it is. Or it's a 6, 7 pair, which would have to be the same as that. And let's go either here or here, which is cruel. I suppose if these are 5s, 5, 5, 5, 5 down there. And 5 up here goes here or here. Where else can we place a 5? 5's into one of those 3. 5's here. It just doesn't really help, does it? Oh, 5's will put 5's there. which does 5s here, which does 5s there. So if this little arrow is a 5, that's where that all jumps around. And that puts 5, 1, 2. Which means, so if this is, if this is 5, 5's there, 5's there, 5 in the middle. 5s and 5s, 5s and 5s. So if this is 5, then yellow is 8. And if yellow is 8, pink is 6. With a 1 or a 3 here. And that's 1, 2, 3, 4. And blue's 7, 7, 9. Why does it all work? If yellow is 8, then this could still be yellow. Oh, what is the end of this puzzle? That's 8. Otherwise, this is a 6 or 7. And it is pink. And what does that mean? It puts pinks like this, puts pink there, puts pink there. Pink is here, pink is up here. So if this is a 6 or 7, that's where it gets placed around the grid. And that means that's a blue up there, so then this would be blue. So wait, is this always blue? No. That's blue and blue. So blue's not 7 anymore. And your other case was this was 5 and then that was 8. In which case this could be a 7 or a 9. Blue is 8 or 9 in that instance. In the instance that that's a pink 6, 7 pair. Pink 6, 7s going around the grid. All merrily like. What on earth is going on? That's not 1. 1s in this box are there. One of these is a 1, isn't it? So that's 1, 1. Or more to the point. Oh no, because one of these doesn't necessarily. Oh, doesn't this need a 1? I'm pretty sure. Because otherwise that's at least 20. Yeah. This thing definitely needs a 1. Like overall. So if this had a 1, then 1s would go here or here, and here or here. And doesn't that just breaks? Because if that's a 1, here we go, then 1s, if this has a 1 on it, should have seen this ages ago, sorry. If this has a 1 on it, then 1s go here or here. We know 1s go here or here. And 1s going in both of those positions, and the fact that they're then on all of these shapes is a problem, because if that's 1, then that's 1, and then this box has no fill. So therefore this would be 1. And this does... No, it doesn't break. You can hide a 1 there. Which is exactly the thing that I saw earlier. Oh no. That's 1. These are 1s. Yeah, you can hide a 1 there. Gosh darn it. So that one, that's 9. Yeah. I'm just going in circles at this point because it's so much of ways that actually all work. The 9 arrow is always 2, 3, 4 because you definitely have a 1 in one of these two positions. And I mean, can you count other digits in like we can't have you can't have all the 3s anyway, but can you have 4 2s in the orange cells? Because you know you've got at least 3 2s in the orange cells. And if you have 4 2s, you obviously can't have one on the edge. So if you had 4 2s, that cell would have to be a 2. Because basically the 9 is made up of 2, 3, 4. I'll make that any bigger. No. And then obviously the can't type. 6 is 1, 2, 3. The 7 is 1, 2, 4. And then that's one of these two. And if it's 1, 2, 5, no, if it's 1, 3, 4, then this is a 2, 4 on the outside. Or if it's 1, 2, 5, you definitely have 2. You definitely have 2s everywhere, and then these aren't 2s. So that's never a 4, which is not the sort of stuff. Not the sort of deduction that really does anything. So that's 4, that's 2 and 5. Yeah, definitely that, and the breaks. Yeah, it is, isn't it? Chad, sure. Because I feel like you can probably give an extra clue and not miss any of the stuff that you want people to do, if that makes sense. And then it flows a fair bit better. It's had the reason I had part of the reason I had the sin is that I had a I think one person raised it a 3-star. Maybe they saw something that we're not. There are 5s and a 5. 2, 4 in the corners means that you are in this situation. And then you got to hide a bunch of 3s, but that's fine to do. Easily fit 3 3s in orange. This has a max of that definitely takes 1s, 2s, and 3s. And those could be because yellow can be 8 there. 4, 5, 6, 7, 8. I'm not missing a non-consecutive rule this time, at least. So we made some improvements. Samu on. See on. No, he's offline. Discord. It's gonna ping him. Ask what we're missing. It has only been 40 minutes. I thought it's been longer. A puzzle. 5s here imply 5s. If 5s here imply a 5 in orange, and didn't 6, 7 also imply a 5 in orange? Because 6, 7 means that that's pink, that's pink, that's pink, that's blue, that's blue. Pink drops down here. Pink will be up there. So if that's, what am I trying to say? If that's pink, then can the central digit ever be 5 and this is pink? I mean, probably. Pinks, pinks, blues. That puts that as blue. So that could still be a green 7 with a yellow 8. Six and 7s, 1s. I mean, if this is 1, then that cell's 1. And therefore this is an 8. But that being 9 is so, that's kind of what you want. How about if this is 9? If this is 9, then green is 9. And green goes around the grid like this. Oops. If this cell's 9, green bounces around the grid. Comes up there. Goes like that, goes like that. That means that would be 9, 9, 6, 3. Then this would be 1 with the 2, 3, 4. This would be a 1. And it just works. 9s. 9's here. 3, 6. The 3. I mean, the 3 doesn't look at anything, does it? The fact that you got 4s, no, because you need 3 4s. Or you don't even need 3 4s. You could have 2 4s. The outsides. If I don't get any further within the next 5 minutes, I'll move on from the puzzle, by the way. Greens and blues. It's also tempting just to put in that these being 5s and see what that actually does. 5s, 2s, 4s in the corners. At that point, once that's a 2, you're 1, 3, 4. Once this is a 5, that's a 2, 4, and you'd definitely be in this situation because you don't have 4 2s. So you gotta hide. But like, just gonna put this in. Like those could be 1s if you want. Wait, it breaks. Oh, thank God. If row 4, column 6. Do you mean row 4, column 6? This cell? Oh, row 3. If these are 5s, then that's 5 there, 5 here, 5 there. Why does that make yellow 8? 5s here. I think I had seen that, but I've now lost it. 5s and 5s and 5s. Fives and 5s and 5s would make green 9, yes. I can see that now, sorry. Because of this 2-4. So green is 9. Why does that make yellow 8? Because 5 and 2, 4. Yeah, because that. Well, no, blue would have to be 8. Thank you for the written down. Sorry, my brain's not going. If these are 5s, then row 7, column 9 is a 5. Yeah. So 5 is on the set of yellow. Is the 8. Yes. Yeah, and it makes that a 5, and that can't be anything because of the 2-4. Right. Very well seen. These are pinks. I think this is the version that doesn't actually do anything, though, does it? Hopefully it does. That's a pink 6-7. Whoops, that's a blue. That's a blue. Blue's not 8 on 9 anymore. That's not pink. That's not pink. Oh, thank you very much, Chad. So yeah, blue is 8 and 9. Blue. Blue's still not sorted. This isn't. What colour's this? This could still be green. If it's green, it's 7. So green at least isn't 8, because that would. Wait, is that true? If that's green, 7, or if it's yellow. If it's yellow, it's 6 or 7. What? But I quite like your thought, Tomasi, that if this is the 9 and that's 2, 3, 4, then this makes that 5. And does that break for some reason? It puts 5s on the outside, so we are in the situation where we have 1, 2, 5. So if that's 9, there's 5s here. But surely this could be a 5, or this could have a 5 on it. But there's a bit of progress at least. This cell in this box. I mean, there's a 1, 2, 3, 4, 5. Blues are the same and pinks are the same, yeah. Orange is a big set that sums to 30. And orange is exactly what's on these cells. These ones dropping down. Two arrows that are 6 and 7. Two arrows with 6 and these two cells are different. No, sorry, these two cells are the same. Nice. Yeah. So if I make those red, I can even. Oh, maybe I'll make them dark pink. goes there and there. And if they're ones, they go here. If they're threes, then who knows? Ones and threes. So they always, if they're ones, then they definitely go on here. Even if they're threes, they definitely go on here. They definitely go on there. Can't find my colours. There we go. So I mean they go there or there. Which I don't really want to mark because it's sort of messing with the orange stuff. So I mean if they were here, they'd be threes. The 2, 3, 4 there. 3, 6, 9. So this could be whatever it wants. If that's a 1, the 1, 7, 8, then that's 9, 2, 3, 4. Surely this should do something. It's ones, it's there. That's 1. Then that's where ones go. If it's 3, then blue is 9. Red cannot be 6. Oh, thank God. That'll be great. 6s, 3s, 1s. See if I can, if I put it in like this, will I be able to see what you've seen? Has it to do with that? No. By the time you've managed to type out an explanation for it. Breaks box 4. 3s would have to go up there. I'm putting in so many digits and I still can't see it. Oh. That's just a red herring to get me off the track. Is this as far as you had to go? Chad. Uh, 2, 4, these would be 5s. I'm going to fill out half the grid by the time you've written out what you've found. Which, to be fair, might be about what you need to do in order to break it. Oh. I mean, if anyone can see anything wrong with this at this point, I'll take it. Yeah. So if it puts 5 on, if that being 6, puts 5 on orange, then the middle cells are 2. Six. Hang on a minute, did we? Is that what we had? Middle cells 2. Yeah. Humbug. Right. 7s. I suppose that's the only other option to try, isn't it? Yeah. Because you have a sort of one thing going on. One of these is either 1. So if that is 6 and that's 3, that has to be 1. Because otherwise, these are 7s and 1s and 1s. And 8s. And 1s and 7s. 6 is actually. If that's 6 with 1, 2, 3. Blue is 8 and green. Oh, so it's blue, green, and 8, 9 pair. I'll just take it. I believe you at this point. So then these aren't 5s. And definitely has a 2. That's not a 2. Six is here. 6 forced to 9. That forced to 7. Then wait, why? When? Hey, you're right. Thanks. We are bashing our heads against a wall at the moment. If you want to join us, I'm not sure if your first statement's true. When pink is 6, then green is 7, yellow is 8. I'm pretty sure. Unless your statement is also true and that it breaks, because that would be a joy. But I think it looks like this, doesn't it? 3s, 2s, 4s, 5s, 2s, 4s, 4s, that sort of thing. I mean, that's kind of interesting that makes that 1, 2, 5. Which is what it is. It do be like that. It is. Wait, no, that doesn't even break this, for God's sake. Dear Lord. This puzzle. It is something. I mean, if blue's 9, I didn't even go back enough. Yeah, we haven't really looked at this, have we? Shall I see how much of the grid I have to fill out in this case? 1s, 2s, 4s, those are 1, 7, 8. I mean, filling out the 1s probably doesn't actually do all that much. He says that, and then he puts 1 there, which might be interesting. No, because I've looked at all the 1s. There's a 6. Anyone spotting anything that might break? 7s. Probably me at this point. There's a 6, 7. In this particular case, those are like that, but yeah, 3, 5, 8. I suppose in this case, you know that 8, 5, 6. It's not exactly looking like it's doing anything at all, really, is it? I thought I'd managed to get rid of those 2s already. Like, if you're able to fill up this much of a grid at this point, and like we did it both ways, then I'm not entirely convinced the puzzle's particularly humanable. Unless we are just missing something. There also might just be... Though I don't know, because Samu makes some good puzzles. It might also just been set and like, I don't know. I don't know. In this, oh no, but you still don't know in this case if you got 5s or 4s. Yeah, I know, yeah. I normally really enjoy this stuff. But I mean, at this point, I've still got things that work either way round, which I just don't understand how that's even possible. Anyone see anything that breaks? That's a 3, 3, 6, 6, 2, 3, 5, 4 pair of 2s, but 5, but 2, 4, 4 in column 3. Hmm. 2s would be there at that point. I'll bifurcate him away to here, at least. I should have, before I filled all this out, saved the waypoint, and so I could go back easily. Like, duplicated the tab or whatever. 6. I mean, I might just claim that this is the solution. 4s and 2s and 5s. It certainly looks like it would be. Uh, 3, 1, 2. Do you reckon? I mean, there's been a lot of us staring at it for a long time. Oh, I thought I'd broken it then. 8, 5, 5, 3, 8. So I think I've stumbled across the solution. I mean, that is entirely possible, to be fair. 5, 6, 6. So assuming that 1, 2, 4. So in pink is, and then to be fair, once you have that pink is 7, that did sort of flow quite nicely. So how do you prove that pink isn't 6? $217 seems more likely now. I've gone too far. That was where I went from. I think, pretty sure I did say that this couldn't be 2. If that's 2, that's 8. 2s and 8s mean that you got, yeah, you got way too many 2s in the outside. Hang on, can those be 2s? Is that the point? That if 2s are there, no, because it's all it's saying is you got 3 2s at this point. 2s, 8s, 9s, but 5s, and that's what breaks. The 2s there. But if those are 2s, then that just makes this 9 and doesn't have the same sort of knock-on effect. Down here, that'll be 5 and 4. But, hang on, if these are 2s, that's 9, 8. That would be 5 and 4, so that would have to be 6. 1, 2, 3. That's the solution, isn't it? Yeah. Surely it's not just a big old sum around the edge, is it? That'll be annoying. He is alive, yeah. It's just a bit sleepy. Yeah, I can feel some purring. I've pinged Samu a message to see if he might be on. Yeah. That's a bit more movement. Give it 4 more minutes. 9 and then skip on from the puzzle. Because, I mean, we've looked at pink is 6, isn't it? That breaks, in theory. I mean, there's a small chance that it doesn't, but people have tested it. So it should, and it's one you could just chuck in a solver as well, couldn't you? You know what? I'm gonna. I'll let him know that you said that. He is a little prick sometimes, but he is very lovely. 8s and 7s and 1s. Yeah, I'm just gonna have a look at this point of what this sort of thing looks like in the hopes of seeing why that might break. 2s. That's not a 6. 1, 2, 3. I've got a message from Samu. Hang on. Let me go back and send him a screenshot. Yellow is broken. Is that actually? Why is yellow broken? Praise be. That's not 4. So yellow would be 8. And yellow would be 2 and 4 in blue, then yellow. Twos. 2s will go there. I can't see it. Am I looking in the wrong place? Still can't see it. Does this not just work? Well, yeah. Sorry, I'm just trying to message. No. Yeah. Is there something you did see, Chad? Or is does this look like this just works? Ones I think I said had to go there. Oh, which did turn out to be okay, didn't it? There's an 8 at least. Yeah, that is a 1, but pause. Ah, right. That 5s. 3, 3. 5 still have a couple of places at this point. I don't even know anymore. 6s. There's a 7. Apparently we missed a set trick. Oh, 2's in this box. Yay. 2 5s and yeah, and 2 5s and whatnot. Hmm. Yeah. I think at this point I'll claim it as vaguely solved. If we've proved, because that was a grid that we did from the 7s being true. And if the 6s break for some reason there with 5s, then that works. Yeah. I'll take it at this point. I'll be interested if because apparently there is a set trick that can play stuff. Yeah. Right. Time is it? 9 o'clock. Let's go for one more puzzle. And I think this one should be a damn good one. Because J Dyers always are. I say always. Yeah. I gave up on what with the clock totally died there, didn't it? Not well, I don't know, maybe we were going for 4 hours. Let me bring up the rules. And I need to message Samu again. I shouldn't take a no. Oh no, I've closed my rules thing. Has it gone? Rules. There we go. Nice. Yeah, I just need to reply to Sam and then we'll jump into the puzzle. Nice. Right. So yeah, puzzle by J Dyer, normal Sudoku standard. Normal killer cage is not repeating, but there are only 4 different totals that can be chosen from it. And cages that share an edge all have to be different totals. And also no digit may appear in multiple cages with the same sum. It's like your 2... Yeah, you can never have... You could have 2 digits without that rule in the same that's the same color. So those 4 are all going to have to be different, aren't they? There are 34 cage cells. Oh, what in total? 2 less. Oh, that is interesting, actually, isn't it? And 2 less than 4 sets of 1 to 9. Two groups of cages must have a total sum of 45. Interesting. I'm not quite following. Why that's true. 34 cage cells. Because of the repeating thing. Taking out sums of 9 and 15. I'm definitely not following your comment, sorry, Damasi. At least 2 groups of cages must have a total sum of 45. Because otherwise... Is your second comment true, Bookworm? With if a group has a total, and by a group, do you mean a single color, or do you mean a pair of colors like yellow and blue all added together, all the yellows and blues? A single color. Yeah, that makes sense. And then yeah, it can, and you can't have so that'll be 3 15s. And you can't have 9 things adding to 5, no. Or anything less than that. And why does one of them have to add 45? Oh, because yes, sorry. I've now understood your second comment. My brain is on the go slow, sorry. So yeah, because 2 of the sets must take all the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. They've got sum 2 to 45 to 15. Hey Summer. Yeah, sorry. We've moved on from this. I will be interested to know the intended route, but none of us could find it after quite a while, unfortunately. And I mean, it's obviously not going to be the color of the single digit. And there's got to be 3 cells that sum to 15, don't they? Of which the 2 ones that sum to 15, they'll both have to take... Oh no, because they could take the triples. I was thinking they can only take at most 2 singles. And of course... Ones that sum to 9. And did you say we've got... sorry, I'm looking back at the comments. We have 3... Oh, we have 3 things that sum to 15. 3 of them that sum to 15 and 1 colour that sums to 9. Which I can't quite see, but I believe both of you. And therefore that has to be a 9. Presumably. Oh, sorry, I've completely misunderstood. No, isn't it 2? 2 colours that sum to 15. Because there's at least 2 sets that have a total sum of 45. That is also true. There's one colour that sums to 15. Yes, because 9 works, doesn't it? Sorry. Oh, dear Lord. I'm needing a lot of hand-holding at this point. Thank you. Hey, Dyer. Right. 1 colour sums to 15, 1 colour sums to 9. Right, I'm with you. And it's not pink that sums to 9, at least. And it has to be done in 5 ways, so it has to take this, doesn't it? Yes. Thank you. Yeah. And it's got to be the green color is the one that sums to 9. Because it's got to take one of these 4 things, and it takes at most one of these, so it's got to take at most one of these. 1, 2, 3, 4, 5. Yes. Yeah. So green is either one of them, or green takes one of those, and one of those, doesn't it? Nice. Hey, Palpot. Right. And then the one summing to 15 is something that you have 3 cages, isn't it? That all sum to 15. Single cage. 4 doubles. So does that tell you anything about... Well, actually, yeah, this couldn't take 2 doubles, could it? Because, yeah, it has to take a size 4 or 3 and a 2. That makes sense. Nice. 2, 3, 4. So it's going to take one of those. But we don't really know what the breakdown of those cages are at all, I don't think. In terms of, like, where a 1 might go. Or anything like that. And of the other 2 colours, both of them have to take exactly 1 digit out of their set of 1 to 9, don't they? And I was just wondering if, because obviously it couldn't be prime, what those totals could be. And this is my last one tonight, I'm afraid, Dory. I'll hopefully start streaming a bit more regularly again. Had a peak near the start, left it for a while. But yeah, hoping to come back. Row 6, column 3. Yes, it does, doesn't it? Because it can't be green. Nice. Good spot. So yeah, so the other 2 that have a sum that sum to a total of one of these things. 37's prime, 41 is prime and 43 are prime, are they? Feels like they should be. Ah. Yeah. Feel free to just DM me or something. Dollar. So let me just. I don't know exactly where these green cages go, but if those three are your other green ones, and if pink took that and whoa, hello, pink took that and that, for example. I mean, could no? There's 2 and 1, 2, 3, 4, 5. Yeah, so I'm saying pink is our 15 sum, and then you've got 1, 2, 3. You've only got 5 cages left. This is assuming that these are the sums. Oh yeah. You tell that I've been doing. Yeah. Yep. I forgot about that one. And can it be the case that no, it can't be the case that one's a 2 and one's a 4, can it? Because that's way too many digits in one. So you are exactly right. They are divisible by 3, which makes this easier. So they either have a sum of these 3 things, don't they? Let's make sure I go back to clear up that. Sum of 12, 13, or 14. And they're made up of, various doubles or triples. Or even, one of them has to have a quad in them as well, doesn't it? I was wondering if there's anything you can say about sort of smaller sets or like the combined sets of digits. Might be interesting. And also what these would miss, because the 12 misses a 9. And like these two miss 8 and 7 respectively, don't they? I've gone the wrong way. No, 14 times 3 would miss 3. And 13 times 3 would miss a 6, wouldn't it? Like the digit that it would avoid. That's what I was trying to go for there. I don't know if I made that clear at all. Yellow, the other 9 cell color. Rearranging cameras. Yellow's 15 because it has a 4 and a 3. Yes. Yeah. Because otherwise it has a 4, 3, and 2. Nice. Thank you. So sum to 15. So pink is going to take. Pink has got to take those like 2 2s, doesn't it? and then blue's going to take another blue. The last triple, I think, is the only thing that can take that one. Because in order for this one not to have three things, not to have 9 cells that are blue, it's got to take both triples. Or for pink not to have 9 cells that are pink, it can't take a triple. So one of these is green, and then the other one would be blue, pink, or yellow in that case, actually. Yellow sums to 15. 2, 3, and 4. Last 3 digits in blue are column 6. Oh, that is a wild. That is a very good spot. Because these 3 digits are exactly those 3 digits, aren't they? So neither of these are blue. Oops. Oh, what am I doing? Those 3 colours. So none of these are blue. Certainly not green, and that's not yellow. And we know that one of these 2 is green. So if that's green, pink, and yellow, that's then all of yellows used, but that's probably fine. Or otherwise that's green, and then it doesn't particularly matter. And blue either avoids a 3, 6, or 9, which then sits in there. But I think this could be blue. It's not necessarily a pink, yellow, green triple, is it? I'm pretty sure. Or do you reckon there is a yellow? Can that not be pink, green, and blue like that? Can't see why this wouldn't work. Yeah, still need the blue too. Yellow's your 15. And I mean, if either of these are yellow, obviously they'd have to be a 7-8 pair. But that could just as easily be like a 9, 1, 2, 3 if it really wanted to. Green we know sums to 9. Is there any more tricks with how these line up that we can use? These 3 cells are all part of the blue set, so then these 2 are. Three blue cells in box 5 go at the top there. Nice. Yeah. So that has got to be less than blue. That's very true. Do we know that? Oh, but yellow, of course, is 15, isn't it? Which is the biggest. Yeah. Sorry. That is cool. So blues, those 3 cells have to go up there. That couldn't be yellow because yellow is 15, so yellow is bigger than blue. And that would be contradiction. Nice. So we found a green, that's got to be a yellow or blue. And you know that pink is less than blue at that point. Because you've got yellow that sums to 15, green that sums to 9, which is the single plus the 4 pairs, and then pink is less than blue. So pink is either from sums to 12 or 13, and blue's going to sum to 13 or 14, isn't it? So I mean, you could pencil mark that potentially, because pink is at least 12. Oh yeah, I suppose it's yeah, what's this unused digit? Oh, that's just whatever's in here, isn't it? Sorry, I had to cough. It is, I'll wake those two up as well. Yeah, I don't think that's an inequality, is it? Damasi, that's just an equals. That pink is blue plus the unused. Yeah. Those three do just sum to blue overall. But yeah, if pink is either 12 or 13, that is very true, because that is a 1 or a 2, isn't it? Because pink is less than blue, and pink comes from 12 or 13, and blue comes from 13 or 14. That's going to be small. That's relatively big. So blue either misses, like avoids a 3 or a 6. I was just wondering about if 9's impacted blue at all yet. This can't be yellow, because it now can't be a 7-8 pair and it's not a 6-9. So that is our last colour blue. Annoyingly, that can still be the last yellow. These two cells go in here, don't they? And these blue sums to 13 or 14, doesn't it? So again, that's got to be at least a 5. Because we've got a lot of high digits sort of going on here, don't we? And if that was 8, that would have to be 6, 7, and this would sum to 12. Which is, yeah, can be done in lots of ways, can't it? There's a virtual 7-8 pair between those two, though, isn't there? Because that can't be 5-6 on its own. I suspect that doesn't help all that much as of yet. Oh yeah, 9 has. Well, yeah, we knew 9 has to go in blue because blue comes from either 13 or 14. So blue either misses a 6 or a 3. If blue is 14, then that has to be 6, 8. Are you saying that can't be 13 at that? Oh, because that's then 7 and 2. That's so cool. Nice. That makes sense. Yeah. So pink is definitely 12. And pink avoids a 9. That is very cool. Oh, it's LMD gone down again. That is very nice with that interaction up there, isn't it? Yeah. So pink is 12. It's reducing. There's a bit of pressure on that. Because it can't be 4-5. Lovely. Yes. And the other one's going to be your other 4-5-7-8, isn't it? Wherever that may be. What next? 9 in column 6. I mean, I think the 9s can. I mean, other than there, I'm pretty sure 9s can go, unless I'm missing something. Can fall in any of these cells. No, 9. Oh, sorry, I was not following because 9 has to be in blue, doesn't it? And it certainly can't go there, so that has to be a 9. Because 9 is definitely in blue. Blue either misses a 3 or a 6. Sorry, the ammo. I'm even saying your name right. Apologies. I wasn't following at all what you're saying. Blue in box 3, you reckon always uses a 6? If that didn't, it would have to be a 5-8 pair, and then that puts 7-2, which is a problem. Nice. So blue always misses a 6, so blue is therefore 14 because missing a 6. Sorry. If it did miss a 6, it would sum to 13, but we know it's got a 6. So it does sum to 14. So that's 6, 8, 7, which makes that a 2. So blue is 14. Pink is 12, green is 9, and yellow is 15. And that now does have to be 4, 5, 6. The 4, 5 virtual. There's no 3 in blue, thank you. So this is 2, 5, 7. We should be able to do this now, shouldn't we? That's 3, 6, 8 with 1s and 4s. Lovely. 1s are here and up there. One in box 5. Thank you. Makes that way around, doesn't it? These come from 5, 6, 7, and 8. Surely that's a big old thing, isn't it? Yeah, there's 1s here and then 3s there. 5, 5, 7 as well. Should have put that in. 3s and 8s. That way around. Lovely. 8's not here. 2's down there. That's probably not worth putting to marking quite yet. So we need to find a yellow 7, 8 somewhere, which I was about to say can't go here because of the 8th bit, also it's touching an 8. So it could go there or there. What else do we need to place? I reckon these need an 8. Oh yeah, there's an 8 there, thank you. So you got a yellow 7, 8 that's missing, a green 3, 6 and 4, 5, and what's the last one? A pink 4, 8. One in row 2. Thank you. 2, 4, 5, 7, and 5. Is that right? Yeah. 3, 6, 9, 2, 4, 7. So do you reckon this always needs an 8? Yeah, because it can't be a pair of pinks. So that is definitely 6 and 8. So that means because one of these has to be green, one of them has to be the green 4, 5, which goes somewhere here. And then can't be with the pink 4, 8, so the 4, 5. That is a 4, 5, 7, 8 pair. And then left over is, so you got 4, 5, 7, 8. You got 3, 6, 4, 8. 3, 6, 4, and 8. So that isn't in fact 5 or 7. That is just a 6, which goes with a 3. That one's green. That one's pink. Nice. Box 8 color. Sorry. Diddle it. But yes, yeah. Assuming that all sounded correct. I think that was all true. But now we've used that one up, and we've used that one up. That's a 4, 5, 7, 8. And in fact, a 1 at the bottom, isn't there? Nice. 4's not quite placed, but I should be able to actually just write in what these are, basically. 5 and 7. The 4 and 9 there. So this, it's not. With what we've got left, that's what we got left, actually. 5, 7 pair, though. Which bets a 2, which bets a 2. 8s and 8s, and 1, 4, 9. Yeah. More 1s. Lots and lots of 1s. Not all 1s, though. 3's there. Up and down here, 2, 7, 2. 7 and 5. 3's. Oh, yes, thank you. That's a lot of triples. Makes sense for a puzzle like this, though, I suppose. 1, 5, 6. 9's not at the top. That's not 7. That's not 8. There's an 8. There's an 8. So that's 8 and 7. This one's your 4, 5. 8 and row 6. Just beat you though. 2, 3, 6. That looks like a... Is that a quad? No. Not quite. Let's make sure these are coloured the right way around as well, by the way. 7's in row 4. Nice, thank you. 7s, 5s, and 7s. That surely does all the 7s, doesn't it? That holds out. No. 4, 5, 1, 7. That's not a 3 or a 9 or a 2. There's a 6, 8 pair, which we can do. And oh, these 6 still working. X-wing on 8s. I think I've got me 8s now, haven't I? Yeah. And 4, 5, 8 and triple. Oh, yes. Nice. Oh, that gives you the 1. Lovely. 4s and 5s, 8s and 5s, and 8s and 4s. That looks like a 2. 3s and 9s, 3s, 3s, 9s. 9s. Nice. 6s. 9s and 6. Awesome. Very cool puzzle. Very cool idea. I would not have seen, for the life of me, the idea of the 45 sets that you have to start off with. That is a cool concept, and nice that they can only be broken down with the 9s and the 15s and such. That is very enjoyable. Very good puzzle. Right, I better shoot off to hop to the shops before they close at 10 to grab myself some dinner. But thank you everyone for hanging out and solving the puzzles. That was very good fun. Nice to be back and doing it again. Yeah, thanks for watching. Anyone else? There's no one else streaming Sudoku, so I can't pass this on to people. But yeah, thanks for watching. Chat to you again sometime soon.